Hey everyone, it's Brian again. I feel like my camera angle is changing every time I record a video. But today we're going to be going into methods. Specifically, part 1 of a 2-part video for our method series. And as to why we need 2 parts, I'm going to get into that in a second. But first of all, let's get into these slides. So what are we learning today? Well, we're going to be learning what a method is, as well as its properties, such as parameters, return types, access modifiers, and this one keyword that we always see, static, and we don't know what it means yet, so we're going to be explaining that in this video. Next, we're going to be going over the technique of recursion, and what it is exactly. And then I will answer the question of why we need 2 parts. So if you're too lazy to read, we're just doing methods. This is basically an introduction to methods. So, first of all, what is a method? A method is a chunk of code that you can use. That's a really simple way of defining it. It contains parameters and a return type, and it looks kind of like this. This is the main method that we use in Java. Public static void main string args. Alright, so let's dissect this. We have public, which is the access modifier. Void is the return type, which means it doesn't return anything. The parameters are what's inside the parentheses, and they are what goes in the code. We'll be going more into that into a second. I meant in a second. And whatever is in the brackets is considered a part of the method. So here are parameters, and parameters are put in the parentheses after the name of the method. So we have the main method here, and inside the main method we have a parameter, which is a string array called args. Alright, so that's the main method. Now, we can see in the bullet points, parameters become variables inside the method. So in the main method here, we are calling a method called print, and we are giving it a string. Alright, so the print method is conveniently placed right below the main method. So we have static void print. So that's the name of the method, and we're calling it from the main method. So we're saying print, and it has a parameter, string name. And in this method, we are saying system.out.println, the name. So we are effectively printing out whatever comes into here. So if I can get a pointer here really quickly, that's awesome. So print is the name of the method. So we're saying print hello. So what happens is that name becomes hello. So hello is the value of the string name. And then we print out the name. So if you were to run this code, you would print out hello into the console. There is also no limit to the number of parameters you can have. So you could have 5 or 6 or 7 or even like 10 or 11 parameters, although it wouldn't be recommended because that would take an insane amount of memorization to, you know, wait, no, not memorization, what am I saying? Next we have return types. So this is about what the method will return. And usually you're returning a variable or an array. So in this example, we have our main method again because Java always looks for the main method when you're trying to run something. So we have integer x is equal to 5. Alright, so we have an integer named x, which has a value of 5. Now we have integer y is equal to add x. Well, what is add? Well, add is a method. It's seen down here. So static int add, and then we take in a number. And then we say int z equals number plus 2, and then we return z. Now note that the return type is an int, not void. So we're returning an integer back to the method that it was called from. So if int x is equal to 5 and we're saying add x, number becomes 5. The value of number becomes 5. And then we do int z is equal to number plus 2. Well, in this case, z would become 7, and we're returning 7. So that means that y would become 7, and then we print out y. So then we would print out 7. I have said 7 way too many times in this period. Last but not least, we have access modifiers. There are 3 in particular that we need to focus on: public, protected, and private. Public means that the method is visible to every single class in the project. Protected means that the code is visible to classes within the package and its subclasses. And private means that the method is only visible within the class that it's in. Now, we're going to go into what a class is in a second, because that probably didn't make that much sense in terms of what classes and objects are, because we haven't gone into that yet. So I'll give a brief explanation when we actually start coding stuff. Now, what does static mean? Well, static means that the method does not belong to an object. And again, I'm pretty sure you have no idea what this means as of right now. But basically what it means is we have objects that we can make in Java, and objects have properties. Now, static methods do not, or rather they are not, a part of an object. If that made any more sense. I don't think that made much more sense, but it's okay. So here's a little example of recursion. Now, I took this sample from W3 Schools, and I haven't even completely gone through this yet. So let's just get into it and dissect this code so we can understand exactly what it's doing. So we have the main method, which is, where we're going to start, because that's where Java always starts. So we have integer result is equal to sum of 10. Okay, simple enough. We can see with the parentheses and the name that we are calling a method. So let's see where the method is. Oh, it's here. So we have public static int sum with an int k. So 10 becomes the argument, or the parameter. So k becomes 10. It has a value of 10. We know that this method is going to return an integer based on its return type. And we know that this doesn't have to do with an object. All right, cool. So we know that much. So if k is greater than 0, which in this case it is, right, because k is 10, then return k plus sum of k minus 1? What in the world? So here's where we get into the definition of recursion. Recursion is calling a method within the method, if that makes any sense. So what we're doing here is we're taking 10, if we're going with our example here, 10 plus sum of 9. Okay, so now we need to figure out what is sum of 9. All right, so we're going to go back to the beginning of the method and say become 9. K becomes 9. And if k equals 0, return 9 plus sum of 8. All right, so now what is sum of 8? Well, we go back in here. If k is greater than 0, return 8 plus sum of 7. Now, we just keep repeating that because we need to find 7, 7 plus sum of 6, 6 plus sum of 5, 5 plus sum is 4, etc., etc., until we get to 1 plus sum of 0. Now, what is sum of 0? Well, sum of 0, according to this method, is 0. Reason being, 0 is not greater than 0, so it goes to the else statement and just returns the number 0. Alright, cool. So, now we know what sum of 0 is. So we can figure out from here what sum of 1 is, because we know that sum of 1, which we were trying to figure out earlier, is 1 plus sum of 0. Now, what is 1 plus sum of 0? Well, that's just 1 plus 0, and that's 1. So sum of 1 is 1. So now we're going to take that and try to figure out sum of 2. Now, sum of 2 is equal to 2 plus sum of 1. Now we know that sum of 1 is 1. We just take 2 plus 1. So sum of 2 becomes 3. And we keep doing that until we reach 10 plus sum of 9, which is our original. Because we know what sum of 9 is, because we're working kind of the other way now. And using that, we can actually figure out the result. So if we were to interpret this code, I would say that it would be 10 plus 9 plus 8 plus 7 plus 6 plus 5, etc. So basically adding the numbers from 1 to 10. And that would be what this code would be. Alright, cool. This is a decent example of recursion. Now, recursion is a very difficult topic, so I recommend taking 5 to 10 minutes to just dissect this code outside of the video, just so that you can gain a better understanding of what recursion is. Now, recursion isn't mandatory. It's not like you don't need it, but it's really good if you want more efficient code. So I highly recommend looking into it. So now let's get into the code. But first, I need to explain why we are splitting this into two parts. And the reason we are doing this is because methods become a lot more different when we start learning about classes and objects. Now, we haven't learned about that yet, and we're planning on learning on that soon. Learning about that. But we need to understand classes and objects before getting into the more complicated properties of a method. And this was already complicated enough, and we just did the intro. So we're going to do classes and objects first before going into the second part of methods. So with that being said, we are going to start coding now. So coding Brian, back to you. Hey, it's coding Brian with the fancy hoodie and everything. So we're going to get into our examples with coding methods. So let's get started here. So let's say we just wanted to, let's say I just want to print out a random number. So let's say print the number 5. All right, that's going to be our method name. Now note that there are parentheses because it's a method that we haven't made yet, and we're going to make it now. So let's say we have static void print the number. Wait, there are 2 T's. Print the number 5. All right. So we have our method, and note that it doesn't have any parameters. And because it doesn't have any parameters, we're not going to be inputting anything when we're calling the method. So there are no parameters. It's just blank. So let's print out the number 5. Or what? There we go. We are printing out the number 5. All right. Simple enough. So if we run this code, we will see the number 5 because, you know, we printed out the number 5. Very cool. So now let's say we wanted to add 2 numbers together using a method. So let's change this to add, and we're going to do static int add, and we're going to have 2 parameters, int first num and int second num. Now note that the parentheses are separated by a comma. So each parenthesis will be separated accordingly. So let's say we're going to have int result is equal to first num plus second num. So we're adding the 2 numbers together and storing them in a variable called result. And then we're going to return result. So we are returning an integer. All right, so that takes out the error here. Now there's an error here in Eclipse because we don't have, you know, we don't have a method with the name print the number 5 anymore. So let's say let's call this some dolphin. I like dolphins. Equals add 2 and 5 and system.out.print dolphin. All right. So a little quiz here. What do you think this is going to print out in the console? I will give you 1 minute to figure it out. Okay, your minute's over. So if we run this code, we will see that we print out 7. Now, why do we print out 7? Because we are taking add 2 and 5. So first num becomes 2, second num becomes 5, and we add the 2 together, return result. So dolphin becomes 2 plus 5, which is 7, and then we print out dolphin, which is, you know, 7. So that's how that works. So that's pretty cool. We're not going to be doing any recursion here because we're not going to be going over that too much. So let's see, what else can we do here? Why don't we print out all the prime numbers from 1 to 100. Now we can actually do that using a method, and we're going to try to do this as efficiently as possible. So let's make a static boolean is prime. That's not prime, is prime. And we're going to take in a single number. So int num. All right. So we have our method called is prime, and we're going to use this to figure out if a number is prime or not. Now, how in the world do we figure out if a number is prime? Well, a number is prime if its multiples are 1 and itself, right? So what we're going to do is we're going to check if any of the numbers modulus a certain number is equal to 0, because if it is, then it's an even divisor. So let's try this. We're going to use a for loop, which is, if you don't know what that is, you should totally check out the last video where we actually covered conditional statements and loops. So we're going to make a for loop for int I equals 2, I is less than num, I plus plus. All right. I'm going to say if num modulus I is equal to 0, then return true. So if num modulus I is equal to 0, and we covered operators in the, I think, episode 5, so you should totally check that as well. So if you need a refresher, you should check that out. But modulus basically takes the remainder of the division of the operators. So if num modulus I is equal to 0, then we return true. So if it's evenly divided into something, then it's not prime. And actually, in that case, we should be returning false. So let's return false. Otherwise, if it goes through the entire for loop and hasn't returned anything, then we'll return true. So if we return something in a method, that completely ends the method, okay? So if we have the number like, let's say 6 in here, all right, then if 6 modulus 2 is equal to 0, it automatically stops the code and returns false. So it'll return back to the main method immediately as soon as this is called. or as soon as this is run through, I should say. So this is our prime algorithm. So let's say, let's make another for loop in the main method. This is definitely not the most efficient way of doing this anymore. I is less than, let's say, actually let's start with 2. Int I is less than 2, I is less than 100, I plus plus. Or we're going to say if is prime of I is equal to false, system.out.println of I. System.out.println I. Okay. I am not speaking correctly today. All right. So what we're doing, we're checking is prime of 2, right? And then we're going through is prime of 2. So num becomes 2. And then it goes through this and checks if it's prime. And if it is, then it prints out, oh, this should be true. If it is prime, then it'll print out the number. And if it's not, then nothing happens. So let's see what happens when we run this. And, whoa, there we go. We got every single prime number from 1 to 100. All right. Oh, wait, you can't see it because it's a little bit weird. But if I change the overlay really quickly, there we go. It is there. All right, awesome. So what exactly can we do with this? Well, this is just an example of how we can actually use methods to our advantage. Because if we didn't, then we'd have to have for loop inside of a for loop. Now, that would work, but it would also be a lot harder to think through. So that's why methods are really important when it comes to thinking about a solution to a problem. All right, Coding Brian, or my bad, not Coding Brian, I'm Coding Brian, but Slides Brian, back to you. Hey, Slides Brian back here. So I think Coding Brian made the overlay really weird, so I'm going to fix that really quickly if I can just get none of the black bars in there. All right, awesome. So with that being said, that concludes our methods video. Now, I know this was really confusing, and it was a lot to take in. It was very confusing for me when I first learned it from Coding Brian, but eventually you guys will get used to it. I highly recommend rewatching this video if you are confused, and maybe searching up some practice problems if you want to test your knowledge. So with that being said, I will conclude this video now. In the next video, we're going to be going into arrays. And then in the next video after that, we're going to be doing classes and objects, and then you will see methods part 2. So with that being said, I am out. Have a good day, everyone. Peace.